over 2 months. Since he lived here, he's one of our residents. So this is gonna be his first talk in here. So I'm gonna read his bio for the information of everybody. So he has more than 50 years of experience in drainage studies, storm water management, and water resources engineering. He acted as project manager on more than 200 projects, providing expert advice on multidisciplinary engineering and environmental projects. His work carried him across Canada and 14 countries around the globe. In addition to his consulting work, he conducted training courses for engineers and technologists on hydrology, hydraulics, urban drainage, stormwater management, and flood control across Canada. He participated in numerous litigations as a technical expert in both the Supreme and provincial courts. He was appointed as an inquiry officer by order in council to review the flooding in Toronto, reporting to the Premier of Ontario. He presented over 30 technical papers at various conferences across Canada and overseas. So without further ado, presenting to you our speaker, Ivan Lorant.
Technology.
Thank you for coming. Originally, I decided that the title of my paper presentation should be An Engineer's Lament. But then I thought, with the word lament, nobody will come. So that's when I changed the title of my presentation, Modeling Earth's Climate's Future. What is going on? Scientists are investigating our climate. You heard an excellent presentation a week ago, what scientists are doing. This week, the accent will be different, excused upon, because my accent will be on what to do. Because I feel that we have to move from what is happening to our climate, first to understand why is it changing, and then how to stop it. And as you heard from the introduction, my background is engineering. So my presentation will be actually in 3 parts. First, very briefly, I want to outline to you the changing climate, the background. Then I'll show you what the climate model is predicting for our future. Time permitting, we'll see whether the gods are smiling and I will be able to connect via the internet direct to the model and show you a few outputs what the model is saying. We'll see how we do. I never trust computers and internet connections. And so what I want to convey to you in 60 minutes, what I learned when I took the 6 months course on climate modeling from MIT. Okay, so the first part is briefly what is happening. There is no question, global temperature. And when we read articles of global temperature, that's an average of over land and over oceans, and it's rising. There's no question, 2024 had the highest global annual temperature record. So I wanted to know what it was. Couldn't find it. It took me days. And finally I found a research paper that the annual temperature in 2024 was 15.1 degrees centigrade. Why is it so difficult? Because scientists, rightly or wrongly, I think wrongly, made the decision more than 10 years ago. Let's not talk about the absolute temperature. Let's pick a temperature which occurred before the Industrial Revolution, between 1860 and 1910, and call that our baseline, 0. So they only talk now about the change, what they call anomaly. For example, in 2025 it was 1.66 above that 0. So I wanted to clear the air. So when the scientists talk about temperature, they only talk about this anomaly. Apparently, that conveys a message that we are in trouble, that there is anomaly. That's why they made these decisions. Sure enough, look at the latest map. The hottest year ever recorded, either in 2023 or 2024 or 2025. Look at the global map. Everywhere you look, one of the 3 years produced the hottest year ever recorded. So what are the impacts of climate change? We hear a lot about warming, but there is much more. I picked number 1 because that was my profession, dealing with rain, runoff, irrigation, flooding, etc. But there are impacts of oceanic, the whole ecosystem, our agriculture, the human health, and social impacts, and finally, economics and the infrastructure. Just think, once we know how the rainfall pattern will change, every city in the world will have to rebuild their storm sewer system. So just to illustrate what I mean by infrastructure. I want to show you some examples of the hydrologic impacts, because this is a very serious matter. One of the first very interesting projects I had when I lived in London, England, was a project trying to protect the city of London from high tides coming in from the English Channel. And it was decided that to protect the city, some sort of barrier will have to be built to protect the tides not coming into the city. And this is what it was built. So the tides, when the tides are very high, that can last 2 hours or 3 hours. They close the gates. The gates normally are flat at the river bottom. But when the tides are getting very high, they raise the gates, and for 2-3 hours, they close the gates and protect the city of London. Problems? Yes, that's fine. But while the gates are closed, the River Thames would like to go out, and it cannot. So what we had to do, that was middle of 1960s, is to estimate what would be the highest tides, then how long the gates have to be stored in close position, and then how much flow is trying to go out on the Thames. This whole design now can be thrown out because the tides are changing, the Thames River flow is changing. Guess what? Until now it worked well. They closed it 221 times since it was open. And now they said, sorry, City of London, you only have protection till 2030. So what they are doing, they are already planning a new structure. So I wanted to show you how this climate change is affecting us, and it's a good opportunity to be an engineer for the next 100 years. The other one example I want to show you, when the Chinese called me to come and provide them some advice, they want to build a large dam. This part of Yangtze is beautiful. That's why it's called Three Gorges. And the problem is that 480 million people live downstream and they get flooded. And during the summer, there isn't enough flow to irrigate their crops. So the Chinese decided they're going to build a dam, 150 meter tall, to stop the high flows coming and temporarily store behind the structure and release that flow once the danger is over. Here is now the project. Why I remember our first meeting, I got my culture shock that I am now in China. I sat down with the engineers, the interpreters, and the Communist Party chief. And they were telling me that yes, they want to build this project. So I said, if you raise 150 meters up the water level, what will happen upstream? You flood all the villages and the people. And then came the answer. Only 1.5 million people. So it shows when you go to different countries, different culture, you have to adapt. So anyway, another project which will have to be reviewed once we know what the new climate will produce. By the way, that cost $30 billion to build. I don't have to tell you much about urban flooding, like this one from a local newspaper article. And then let's look at another problem, water supply. Just, I'm sure you read in the papers the recent upheaval in Iran, Tehran, demonstration and so on. What triggered off? No more fresh water available for 16.8 million people. Why? Because the Jajud River last month looked here. No flow, no water supply for the people. Change of climate. I wanted to show you one of my favorite projects, which I looked at, was the Panama Canal. My wife and I took an Oceania cruise line to go through the Panama Canal. I was anxious to see how it works. So when I met the captain, I told him if I am allowed to go to the bridge to watch how we go in and how the system will lift this huge ocean liner. He said, you know what? before we went to Panama Canal, why don't you give a talk to the people on the ship? So, I reproduce here one of my slides, which I used in the presentation. So the problem was how to cross from the Pacific to the Atlantic. Well, they decided to build 3 locks at one end and other 3 locks at the other end, and build a freshwater reservoir. So what happens? Well, they used freshwater flow to move. So watch what is happening. How the locks are opening and closing, lifting up the ship, then going down. And that's how they cross, either from Pacific to Atlantic or from Atlantic to Pacific. The problem is every crossing will lose 500 million liters from the reservoir because it will be spilled either in the Pacific or the Atlantic. What's happening? There isn't enough rain, so the reservoir is never full. And originally daily crossings were 50 ships, now 24. What the result is, ships either have to stay for long waiting when their turn comes up, or go around South America, burning more greenhouse gases and increasing the cost. So another example. All right, so that was what is happening, the impacts of what's happening. So let me talk about why. And the culprit is the carbon dioxide, CO2. These are the actual measurements taken from the atmosphere of the amount of carbon dioxide, parts per million. In 1960 it was 320 parts, and in 2025 it was 427. So obviously something is happening. Then the scientists went to the ice field and took core samples, and they found, going back 800,000 years, the CO2 level was always below 300 parts per million. Well, now you see it's going up. The greenhouse gases mostly are carbon dioxide, methane is another one, and vapor can make up the 100%. Now this CO2 cycles between the atmosphere, goes down to the ocean or land, back up into the air. And now comes the most important part of the greenhouse effect. So when we burn all these, this is a coal plant, 20% of what the CO2 produced here remain in the atmosphere up to 1,000 years. In other words, all the sins, what damage we are doing now, is sitting there for years to come, and there is nothing we can do. The scientists call this the particle effect. The emissions are very high in CO2, but they stay in the atmosphere, and only a small amount is removed. So, okay, so what can we do? policies should be introduced to try and mitigate as much as we can the effect of climate change. And that's when the model comes in, the climate model. Now what the MIT model did, the modelers decided to take the globe and surround it by a grid system. Now they picked a nice round figure of 100 kilometer by 100 kilometer grid, and that grid is now covering either it is a land or an ocean, and it includes the atmosphere. So altogether, 51,000 grids made up the entire globe. But the problem was that in order to model the climate, in each grid, scientists had to set up all the parameters which influence, and there are actually 20 input parameters they have to include in each grid. Then they have to decide what time interval to take to run the model. Should they look at every week, every 10 days, or 30 days? And that influences the computer's capability to churn out the data. The current models use 30-day time step for each 51,000 grid, using the 20 input parameter. So for each model scenario, the modeler is doing 400 times 9 zeros calculations. So you require enormous, powerful model. And they are trying to reduce the time step to weekly, but at the moment there is no computer capable to live with that. So, okay, MIT model. The financing and actually the whole impetus of the model came when John Kerry was appointed as special presidential envoy for climate a few years ago. And he wanted something he can carry as he visited different countries to convince them to start thinking about climate change. So what he asked the modelers in 2021, all right, this is a very complicated model, I understand it, but make sure that the input graphics and the output graphics are simple enough that non-scientists or researchers can still understand. And that's why this model is now used by decision makers. And also, for example, the December conference of parties, which now every year is debating climate change, was using this model to discuss how to try and introduce future control measures. So, what comfort can we have that this model is good enough to predict future climate change? And this is what the modelers have done. They said, we don't know the future, but let's see how the model managed to predict what we know. So, in other words, they went back and they asked the model, they put in the gas production for every year, and they ask the model to predict what should be the global temperature for that year. And again, the graph shows using the 1860-90-10 average. So what you see, the gray zigzag, is the annual global temperature observed by the highly respected UK Met Office. The brown one is the annual temperature observed by the US NASA. And this is the MIT model. So what the modelers are saying, look, we don't know how good a model is to predict what will happen in 2100. But we can show you that for 30 years, it worked jolly well. So what can the model analyze when it comes to control policies? Well, first of all, it will ask you, how do you want to generate your electricity? Coal, oil, natural gas, or more friendly, nuclear, or wind, or solar. How do you use that energy? Well, the industry is using it, buildings are using it, transport is using it. Transport, by the way, includes all our EV production, electric vehicles. Then nature-based control policies. We know that the forests are helping us to absorb CO2. So control policy, encouraging forestation, changing some of the agricultural practices, or producing less waste or leakage of fertilizer. So there are various control policies one can use as a policy scenario. There is a very important limitation with the model, because the model assumes that all these policies one is investigating will be adopted globally, which is a very, very important step. So what will the model produce then? Under the list of impacts for the policies. First, it will describe how the concentration of the greenhouse gases is changing, and that, of course, will be linked to temperature change. Then it produces extreme weather maps showing where population will be exposed to, say, extreme heats or very high floods. It predicts changes in ocean and sea level rise, loss of lives, and flood risk maps. Ecosystem. It shows maps where there will be danger of droughts, wildfires, and gives statistics of expected extinction lists. Regarding health and economy, it produces predictions of changes in air pollution, crop yield losses, and losses in production. So all this, I want to share with you my comments after playing with the model for more than 6 months. I think climate modeling is a combination of art and science. I admit climate models can do a pretty good job when they predict climate and impact, but not perfect, I have to admit. But what are the tools we have now to predict future? It's only models. People are asking all the time, how accurate is the model? We don't know, because we can't compare the model's prediction for the year 2100 with what actually was observed. So we cannot, because we don't know yet the future. So here are some of the more comments on the model. It was in 2015, this rather well-known meeting in Paris, when the leaders of the world decided we have to limit this increase in temperature and limit it to 1.5 degrees centigrade by the year 2100. Coming 10 years later after that, the recent 2025 meeting in Brazil, 195 countries attended, and only 80 made the voluntary resolution to move away from fossil fuels. So I'm really worried. And some of those who didn't sign on include even powerful countries like our southern neighbor. I stay out of politics, so I won't comment. So here are some examples from the model. And the reason I want to show you is when I managed, first of all, I'm not sure I will manage to get into the model, but even when I get it in, so you have a first introduction what to look for. So I asked the model two different scenarios. One, what has been currently approved and built policy. And then the ideal one, that globally we stop burning the three greenhouse gases, coal, oil, and gas by 2060. And of course replacing it with wind or solar. So, here is the first thing the model showed me. Here is the time scale, and here is the energy produced by the different coal is the brown, oil is the red, and gas, natural gas, is the blue. And that's what I said. We assume not to continue building more browns, more reds, and more blues. So I said to the model, tell me what will be the global temperature in 2100. The model said you will increase by 3.3 degrees. Remember the 1.5, how far we are from that. Then I said, predict the future climate if we stop burning all coal, oil, and gas by 2060. Look what the difference. You see the coal, brown, the red, oil, and the gas, blue, go down to zero around 2060. So I asked temperature in 2100 went down to 2.6. Remember the current policy is 3.3? Yes, there is improvement, but not 1.5 degrees. And then I'll show you the policies. First of all, what happened? What happened to the CO concentration? This was the current policy with the 3.3, and when we stop using coal, oil, and gas, let's assume by 2060, it is still showing high values, and that is why the temperature is high. My first reaction would be, why not go, if I stop using oil and gas, why is this line not going down to zero concentration? Why? It's the bathtub effect. In other words, that CO2 is still sitting up in the atmosphere. Okay, so quickly. Here is a snapshot of predicted extreme heat days in year 2100. And the color, red, here is the states, you see, Los Angeles. Here is Central America. Here is South America. All these dark reds mean that half of the year, 181 days or more, the temperature will be above 32 degrees. Here is a map of flood risk because of higher ocean, sea levels. Some of the islands, countries will virtually disappear. And here is Florida. Other data are presented not in a map, but in a graph. Here is one showing expected death from extreme heat. That's per 100,000 people per year. And you see how it is increasing, and by 2100, estimates 2.5 million people from extreme heat. Other graphs, extinction risk of species. Marine species, 27%, land species, 10%.
That's 27% of the existing species will be extinct. That
All-
1/4 of the existing species will be gone.
Yes. I'm sorry.
No, but I think that's where you can stop and let us all breathe.
So my final thoughts, your timing was right. Will there be political will to try and introduce controls? Well, that's my answer. So shall we attempt and go and see whether we can connect the model, just to give you a taste of what the model looks like. And so we go out. Thank you. So here is the scenario when I said to the model, just tell us the current policies. So you see there is still brown, still red, and still blue. And then I went up. Now I have to figure out where is the first one. Here.
Yeah.
So this map, now I'm connected to the MIT model, and this is the map of extreme heat days. And when I go you see, I can increase the scale. The reason why I want to do is I want to show you extreme heat prediction for British Columbia. And I see is Vancouver at the bottom. So we expect that the days per year about 32 degrees centigrade will increase between 1 and 7 days. My impression after using this model, all these changes regarding whether it's heat or anything else, we are living at the right place here in Canada compared to other countries. Let me show you other countries. Let's go down to the States. Look at Florida. Half a year. That's nothing. When we go to further down, look at that. Look at it. Or we go over to Africa. Look at it. So that's what I mean, we live at the right place. Here is another one, sea level rise. Let me show you the prediction for Vancouver area. Look at it. I hope you don't own any land or buildings down at Richmond or at the Delta area. Because according to the model, by year 2100, that would be underwater if no protection is provided. And as I said, there are countries which completely disappear. But let's go to the next example, and that is drought. Again, Canada looks fairly well positioned because the likelihood of 12 months of drought is very low, 10% in some places, or between 11 to 33%. Now let's look at, as we go south, look at Mexico, or look at South America. So this is what I try to tell you. The beauty of the model is that it helps us to show what the impacts are, and it gives us enough time to see, to prepare how we can protect people. I think I had enough. I'll stop. And so, if there are any questions or if you want me to look anything else, while our connection to the model works, it can be interrupted any minute now. But yes.
Where do they get the fresh water in the Panama Canal?
Rainwater.
Okay, that's
Just
rainwater.
just rainwater.
Just rainwater.
Yeah. So
And
they have a
because there is
reservoir.
less rain,
Yeah.
they were looking for building another large reservoir.
Yeah.
But if there is little rain and the country Panama is so small, it's very difficult to find.
So would they just have that in a huge reservoir that would?
Yes.
Go? No lake
No.
feeding or anything, okay?
Nobody looks very scared, which is good. I was afraid that my lament will produce some worried faces. Be prepared. So come around in year 2100 and see whether I was right.
Can we meet again? Same time, same place.
So to build, drill baby drill, that's not really what you think is a good idea.
Yeah, that's right. I didn't want to go into any politics, but now that you raised an issue, I read this morning the introduction Mark Carney said yesterday at Davos, because it can apply to us. He said, today I talk about the rupture in the world order, the end of nice story and the beginning of a brutal reality.
Yeah.
And he wasn't talking about climate. He was talking about something else, but it grabbed my attention. So, that's the engineer's lament. Yes. Yes.
And what-
Sorry, ladies first.
I understand what you're saying, but aren't we between a rock and a hard place? Because if you stop using all the oil and
Yes.
the more the economies collapse and the huge time of poverty and illness, how will the world function?
Yes.
We're so addicted to those.
I agree with you. One of the graphs where I showed you that the brown line goes to zero, the red line goes to zero. It also showed the green line, which is the wind, solar, or nuclear. The model will tell every country or the global figure how many more clean energy will be required, meaning how many more wind, solar, nuclear will have to replace the coal, the gas, and the oil. So we are not doomed. There are alternatives. But there are alternatives. The problem is that there are so many interests in keeping going. I had a fascinating discussion when the Saudi royal family asked me to go down and help them to design irrigation systems, because they said we have to, sooner or later, produce our own crops. They saw the writing on the wall that their oil will be less and less marketable. I had to break the sad news, because what they said, let's go use groundwater, irrigate the crop. So we hired a German company to go and drill. They went down almost 1,000 meters before they found groundwater. It was hot and saline. So my report was, I decided first I break the news gently to the prince. So we set up a meeting. I still remember, went at 9 o'clock to meet him to break him the news. The secretary who received me said, sorry sir, the prince had to fly to Switzerland to collect his watch, but he will be back tomorrow. So I brought the news to him then. Sorry. So that, yeah, there are problems all over the world.
I keep thinking.
I understand there is no limit to solar energy. The sun is so strong.
Yes.
So why don't we do it? What is the hindrance? It's not that expensive, is it?
No, and costs are coming down. China is now the leader, both in research and production. It still uses energy to produce the panel, so we have to be careful. It has a useful life of 20, 30 years. It has to be replaced. It's being replaced in more and more countries, but there is opposition because they have financial interest in to continue using oil, coal and gas. Also, wind generated. Yes, it can kill the birds. Yes, every 25, 30 years, the blades will have to be replaced. So there are some disadvantages, but it can be very useful. Yes?
Adding to Hanno's question, solar panels currently are most effective at a temperature of around 17 centigrade. As that temperature goes up, you might think Alberta could have lots of solar panels. Currently, current technology, solar panels will not be working in Alberta because it's too warm.
Know that.
Good to have a scientist here.
And I also wanted to point out that each one of your scenarios assumes that all the countries in the world
Yes,
agree to do it.
yes.
And I think the likelihood of that is not particularly good.
Not at the moment. Not at the moment. Well,
Unbelievably interesting. You're just a wonderful person. And with all your
you
experience.
heard that?
I got it on video.
Excellent.
I know. Thank you so much.
Well, thank you for coming.